Welcome you all to the other session. In the previous session, we have seen SR flip-flop and D flip-flop. SR was standing for set reset flip-flop, and the other flip-flop which was seen was D flip-flop. That is, D stands for either data or delay flip-flop. In this session, we are going to see about JK flip-flop and T flip-flop. J and K are the like characters which was derived from the inventors of that JK flip-flop. From those names, the scientist names, the first letters has been taken and named it as a JK flip-flop. Now let us see how JK flip-flops looks first. Now JK flip-flops look, this is my JK flip-flop. I am talking about JK flip-flop. So JK flip-flop I am drawing using a NAND gates. You can observe clearly. This is my NAND gate. This is also one more NAND gate. At the output side you have cross coupled values which is going to generate always Q and Q bar, right? Again my input values. So this is my input value J. I am having one more input value K, right? But again along with this thing we are going to give one clock. After clock, this one more input will come from external. This is the way how it is connected. Again for this one also we have a connection here connected like this. So this is the setup for my JK flip-flop. Now my first one, transition table, means how the values are getting transited under JK flip-flop. Similarly we have seen for SR flip-flop and D flip-flop also. So the transition table. So transition table for my JK flip-flop. So J and K are my input values and output I am going to write for this transition table. So two variables, four combinations I am going to have 0 0, 0 1, 1 0, 1 1 combination. For 0 0 the output is always no change. That we have seen for SR also. Same thing will come for J and K also. Similarly for 0 1. For 0 1 it is going to be reset state, that is 0. Same for SR flip-flop. For 1 0 combination it is set, that is 1. For 1 1 combination there was, for SR it was undetermined, now it is toggle. T. Toggle means if I am providing 0 as input, it will produce 1. If I am producing 1 as input, it is going to produce output as 0. Means it is getting shifted from 1 to 0, 0 to 1, 0 to 1, 1 to 0, 1 to 0, 0. So such a situation we call it as toggle case. So this is the transition table. Coming to characteristic table. Characteristic table. Now characteristic table, why do we require? To get my present state, means for what present state my next state is going to represent. So along with J and K, I am going to have my present state and my next state values. So for 0 0, 0 1, 1 0, 1 1. So present state can be either 0 or 1, 0 or 1, 0 or 1, 0 or 1. Now for 0 0 condition, you have seen that is my output is no change, means whatever my present state is there, next state will represent the same thing, that is 0 1 only. Next for 0 1 condition it is reset, means irrespective of my present state my next state is always 0. For 1 0 the output is set, means irrespective of my present state next state is always 1. For 1 1 it is toggle, means if my present state is 0, next state will be 1. If my present state is 1, my next state will be 0. So this is what the characteristic table for my JK flip-flop. Coming to my excitation table, the last table, means I need to observe the behavior of my circuit from output to input here. So excitation table. Excitation table, that is Qn plus 1, my inputs J and K here. So 0 0, 0 1, 1 0, 1 1, right? Now for these things let's just observe using our characteristic for 0 0 input. So Qn and Qn plus 1, 0 0 combination exists here, 0 0 exists here. So but my values J and K are, it is 0 1 and 0 0 and 0 1, means K is changing from 0 to 1. So 0 don't care is my answer for 0 1 combination. So 0 1 is present here, 0 1 is present here also, but my input combination is 1 0 and 1 1. So that is K is changing from 0 to 1, so 1 and don't care. Next 1 0 combination, 1 0 is here, 1 0 is here, so 0 1 and 1 1, J is changing here, J is changing 1 here, right. Next the last combination, 1 1 combination, that is 1 and 1 present here, 1 and 1 present, means 0 0 1 0, that is J is changing. I told you for SR flip-flop that I need to observe the flow of my output values, whether it is in the reverse order or not. Let's see, 0 1 don't care, it should be in reverse order, don't care 1 0, right. It is in reverse order, means the values which were calculated for my JK flip-flop is absolutely right. Now let us get the Boolean expression for my Qn plus 1. Now Qn plus 1 as my output value, I am drawing my K map here, and my input values are Qn JK. So 0 0 0 1 1 1 1 0 0 and 1, right. I have ones at 4 places, 0 0 1 1 0 0 1 0 1 1 1 0, 4 places I am having those values. Let us mark them here. Let's mark with a different color, green color I am choosing. Now those are 1 1 and this is 1 and this is 1, right. So I can take a pair like this, I can take a pair like this, right. Now my final expression, Qn plus 1 is equal to, now for this particular thing, it is on upper side J is common and on the left side J Qn bar is common. Next for this particular thing, Qn is common, on top K is common, right. No, this is K here, this is J here. For this one, 1 1 and 1 0, means J was common here. Let's remove it once again, eraser. I am removing it, I will represent it again. This is J Qn plus K bar Qn. So this is J Qn bar and this is K bar Qn. This is my final expression for my JK flip-flop. Okay. Let's get into the next flip-flop, that is T flip-flop. T flip-flop, right. Now T flip-flop is here combining J and K terminals. For D flip-flop what we have done, we connected S with R using a inverter there. Here directly we are going to connect the values here. Now observe it clearly. This is my NAND gate, this is my NAND gate, this is one more NAND gate, this is the other NAND gate. I am having a cross coupled connection at the output level, right. So I am combining, this was J, this was K, my input here it is T here, right. A clock will be provided here, clock. This connection goes similarly to that of my previous case. This connection also goes similarly to here. So this is Q and Q bar, right. So this is T flip-flop. Now let us write the transition table. Transition table, my inputs, outputs, that is input is T, right. So for T value to be 0 or 1, either one variable can have only one value, either 0 or 1. For 0 it is going to have no change, means nothing will be changed, same thing is going to be represented, no change. For 1 it is toggle, right. Next my characteristic table, that is T along with my present state and next state. T can be 0 for present state 0 or 1, T can be 1 for my present state 0 or 1, right? For irrespective of, like for 0 it is no change, means irrespective of my present, like my whatever the present state, the same will be my next state for this particular thing. For 1 it is toggle, if it is 0, if it is going to be 1, if it is 1 it is going to be 0. So this is my characteristic table for my T flip flop. Now excitation table, that is Qn plus 1 and T. I need to observe from output to input, that is 0 0 0 1 1 0 1 1 combination. Now for 0 0, so for 0 0 T value is 0. For 0 1 0 1 combination T value is 1. For 1 0 combination, for 1 and 0 1 0 combination T value is 1. For 1 1 combination, T value is 0. So this is my excitation table. Let's get the Boolean expression for my T flip flop also. So T flip flop Qn plus 1, this one, only two variables are there. One is T, the other one is Qn, 0 and 1, 0 and 1. And if you see, you got only two ones here. That is for 0 1 and 1 0. For 0 1 is 1 and 1 0 is 1. Only two values. So let us map them now. There is no combination that exists here, so I am taking isolated ones. Isolated ones has been taken. So my output expression Qn plus 1 is equal to this one particular thing, this T Qn bar, for this one T bar Qn. So this is my finalized Boolean expression, right? So this is what about T flip flop. There was one like a disadvantage in JK flip flop, like you seen for 1 1 combination there was a toggle, means for present state if it is 0 it is becoming 1, if it is 1 if it is becoming 0. This toggle state can be eliminated using two things. One is by decreasing the time delay at the input level with respect to my clock, so that I can eliminate this toggle case completely. Why? Because if it is entering into toggle state, the machine remains becomes to an uncertain state where it gets completely toggled for a continuous time period. So we need to eradicate it. For like how we are going to eradicate? By providing a clock period which is less than that of that toggling period, so that I can remove that condition completely. The second solution for removing the toggle case is by providing a master model and a slave model. Means if I am having a JK flip flop, one should be a master, the other one should be a slave model. Using this particular combination, I can get my output clearly without entering into my toggle case. Okay. So this is what the information related to JK flip flop and T flip flop. We are ending here. We will continue in the next session. Thank you.